Hey, what's up everyone, and welcome back to another video. So 2 weeks back, I made a video on staying up to date with programming trends. And in that video, one of the tips was to follow Reddit communities to kind of see what's popular within the space. I was doing that the other day and I stumbled upon a Reddit post which was labeled, "What are your glad to have met you packages?" I checked it out. There was a bunch of good stuff there. And so in this video, we are going to cover 5 libraries specifically that you might not know now, but after this video, you'll be glad that you do. All right, the first library we're going to talk about today is tqdm. No idea what that stands for, but what you use this library for is a progress bar in Python. And this might seem like a simple thing, but it can be very useful if you have a big project that has long-running tasks and you kind of need to monitor progress of how things are executing. So to get tqdm, you can go ahead and do a pip install tqdm. I don't know if it comes default or not. And then we could do from tqdm import tqdm. And then what it's going to help us do is, let's also, how about import time real quick? What it is going to help us do is we could do something like for I in range, how about 10,000? And we might, do time.sleep 0.01 and run this, right? By default, this is running, but we have no sense of is this frozen? Is it actually running? You can imagine this time.sleep is replaced with any old code in the world. It could be anything. And we just, by default, I don't know if it's doing anything. I think back in the day, my solution to this was I could do something like if I mod 100 equals 0, print I, and I could run this, and I could slowly monitor the execution. But it's kind of clunky to see these numbers kind of pop up on the screen. So a better solution is leveraging tqdm and surrounding this. All you have to do is surround this with tqdm range 10,000. And if I run this, we now see a nice looking progress bar that monitors exactly where we are in the loop. So I can have the peace of mind that my code is executing and I'm making progress. You can also add nice little things to this. So imagine if you have a bunch of different progress bars running, I could add a description. I could just do this like basic loop. I could call this whatever though. So if I was doing a certain task, I'd probably name it something according to that task. If I run this again, we now see that it's called basic loop and that is executing. So that is quite helpful. It doesn't need to be a range object that you do this on. It could be a list. So you could have a list of numbers, how about, or like list of objects or strings. So how about people names? And I could do a print name for name and yeah, exactly like something like this. And we see that there's a progress bar for this as well, and it executed, fully. If you had a more complex list comprehension, this might be different. These are the basics of tqdm. Can be very useful to monitor things, especially when you have long-running Python tasks. Check it out. All right, the next library that we're talking about today is called rich. So we can install this by doing pip install rich. This is helpful for formatting text very pretty manner when we're printing things to the console. So as an example, how about we get rid of this terminal. How about we define a dictionary with a bunch of Shrek information. So I'm going to say create a Python dictionary with a lot of information on Shrek. GitHub Copilot and Copilot chat is pretty nice. Okay, so we got this nice looking Shrek info Python dictionary. If I was to just go ahead and print this out, we might get a little bit overwhelmed by the result. So I run this, we see we get all of this dictionary information here. It's kind of a lot to take in. It's not super neat. So the first thing that we can do with rich is I could go ahead and do from rich import print. And this is going to overwrite the default Python print. And what that's going to let us do is it's going to print this out in a very nice, clean manner. It also does this. So if I commented or deleted Shrek info, we also can just do this with other random things. So A equals 5, B equals 3. I could do, print I don't know, something like this, run it. We see it kind of formats things nicely. If I remove this line, it starts coloring things. It does all sorts of things by default nicely for you. So one reason to use print rich, but if you want to get into more sophisticated things, we could do something like def compare numbers. So we're going to import now this from rich.console, import console, and we're going to define console here. And now we'll call this function compare numbers, and we'll see what this does by default. So I run this, and now how about actually let's run some compare numbers. Okay, so we have 3 examples here. I run this. We see that it formats it. I can also add different styles to things. So I could do style equals bold green here. I could do style equals bold red here. And if I run this, we see we get colors. This is helpful. Imagine you have tons of print statements and some code you're executing, and you need to find specific things. If you want to style things specific, console.print can be quite helpful. Other things that are helpful here is you could add your own custom theme. So I could do from rich.theme, import theme, and then I could define a theme as, let's say, error equals bold red, warning equals bold yellow. How about? That's perfect. I add my theme to my console, and then instead of doing style equals bold red, how about I do style equals warning here? So we'll see the A less than B case now be yellow. Cool. Other cool things about rich, we could do from rich.traceback, import install. We added install line to the top of our code. And now let's say I do compare numbers, but I do something that I know is going to break this. So I do 5 and I do my name. I'm trying to compare Keith to 5. And if we run this, it outputs a error message that's, very, pretty looking. So we see that just nicely formatted traceback error message. Whereas if I removed this line and I ran this again, we get an error message, but it's kind of hard to see exactly. So traceback can be super helpful. Another cool thing is you can add a console.print, and we can do something like log locals equals true. If I run this, should work. Why is log locals not working? Oh, I realized that in addition to console.print, you could do console.log, which I think adds a timestamp, but that has this log locals. And if I do this, we see that we get a timestamp now, and we get the local variables here, which can be super useful if we're running a loop and want to see everything that's being passed into it and where errors are being caused or something. Cool stuff here. That is rich in a nutshell. I'll add a link in the description to more information about rich, but some useful stuff here. Next, let's talk about pathlib. So pathlib is a standard Python library as of Python 3.6. And what we might use pathlib for is, imagine this example. Import pandas as PD, and then we have a data file. Let's say our file path is something like data, or in the current directory, data/test.csv. So if we look at our repo right now, we see we have data, we see we have test.csv. So this is the file path there. I can very easily load the file in pandas by doing df equals pd.read file path, and then maybe I print out our data frame. So if I run this, we will see our data frame, right? We see it right there. The thing that's interesting though is if I navigate away from our current directory, and now I'm in this code folder, if I now try to run this file, so it's called good to know libraries 03 pathlib, it's going to error out because it can no longer find that ./data/test.csv. So there's multiple ways to solve this issue. The traditional library that you might use is this OS library, but recently the kind of Python standard is to leverage this path library. There's some niceties of this being kind of an object-oriented way to navigate paths. So how I would do this with the pathlib is I might do something like file path. We're on this file right now is path underscore file underscore. So this would give us the path to the specific file that we're working off of, so that the code is in right here. If then I do .parent, this will give me the directory that this file is in. So it's going to be the good to know Python libraries directory. And then I can go ahead and do /data, and then I can do /test.csv, and that would get, this syntax allows me to get specifically into that test.csv folder. Sometimes you might also want to call a resolve to make sure you get the absolute path, but I don't think that in most situations it will matter too much. But if you ever need to make sure you get the absolute path, as well as if there's like a symbolic link or something, you probably want to surround everything with this .resolve. But now what we'll see is if I, again, run this, Python 03 pathlib, we see that it works. If I navigate to a different directory and run Python, good to know Python library 03 pathlib, we see that it still works. So it's a little bit more of a robust way to access different file paths. There's some other niceties, such as like I could do, let's say path .home and get our home directory. So if I print this, you're going to see the absolute path to my home directory. So we see users/Keith Galli. I could do something like code, and we'll see that what this gives us. Cool. All sorts of cool things that you can do with this path library. All right, the fourth library we're going to talk about today is called Pydantic. So to install it, you can do pip install pydantic. And this is super useful if you are trying to check types and enforce types in Python, which is not, something that Python is traditionally known for. So imagine I wanted to define a class called account. In normal traditional type Python syntax, I might have something that looks like this, right? And then maybe my balance is a float, maybe my name is a string. And if I define an account, and then I printed out the account, right? This is, standard traditional Python syntax. But I think one thing to know about this is that if I printed account.name, how about, there's no issues. But if I, let's say, set my balance to some string that was just like hello, and, try to print out account.balance, by default with Python, no issues. It's like, yeah, that's chill. Do whatever you want. It doesn't matter what we define balance as a float. But in Pydantic, this does not fly. So I can't set my balance to like a string when it's supposed to be a float value. So let's go ahead and try this again with Pydantic. So from Pydantic, kind of what you'll typically do is import this base model. And so now we are going to define our class account as a base model Pydantic. We can just call it like this. And this is now set up in the same way where I can define my name, I can define my balance. And I run this and we see an error. And I think to make this video go full circle, if I do from rich import traceback and I do traceback.install, we can see this error message in a more pretty manner, which is cool to see. And it's basically saying, okay, input should be a valid number, unable to parse string as a number. So, okay, if we change this to, how about 100, it will work. And maybe this is a checking account, let's say. I don't know if this is a good analogy because Bank of America, they'll let your account go to negative. Not that I would know, but let's say you can't have a negative balance. We can also define a custom field validator with Pydantic. And what we can do with that is we could set up some custom logic. These autocompletes are amazing. To yell at us if we try to set something that's invalid. So now I have this code. If I try to run balance equals 100, we should see no issues. I also wonder why I didn't print my account.balance here. That's weird. But now if I try to set this to -10, we see we get an error. Value error, balance must be positive. So that is cool to see. I wonder if this was an int, if it would actually show this. I don't know why the float values weren't showing. That is so strange. What happens if I remove this? Oh yeah, now it shows. I don't know why the custom field validator is causing it to show as none. Maybe if value else, maybe this will work. Probably didn't have it fully completed. The issues, I guess, sometimes of doing AI completions. Okay, -10 doesn't work. If we make this now a float, I think it will show what we expect. And we make this 100. Yeah, now it shows. Okay, so custom field validator. We also have the ability, so maybe we have like a password associated with our account, and this is sensitive information. So if I had a very advanced password such as password, and I printed out my account by default, oh no, that's being logged, and I can see my password right there. But there's other like kind of built-in Pydantic things such as secret strings. And if I now make password a secret string and I try to run this, we see that it automatically hides that information. So super useful if you're like, trying to avoid logging sensitive stuff. We can also add some custom type logic to this. So imagine I tried to set my balance after the fact to be -100. If I run this, it's totally fine with me doing that, which should be an issue. But if I do pass in validate assignment equals true here, and now try to run this, it will complain about that reassignment of the variable. I could also do other things, like I could make my name something that's, so I can import something called field. I can say my name needs to be min length 3, max length 50. And I could also say that this is frozen equals true. So if I ever try to change my name in my code, so maybe I try to change my name to Humphrey, good name. It's going to yell at me for that. I guess maybe first let me fix this error. So it is now yelling at me because the field is frozen. So I can't change it to Humphrey as I wanted to. But now it will let me once I remove that frozen field. So lots of cool stuff you can do. Custom validators, things like secret strings. There's also like you could import like an email string. So if you had an email, you could validate automatically using the type email string that it is an email. That is Pydantic in a nutshell. Hope you find it useful. Very useful for bigger Python projects. All right, the fifth library that we're going to talk about today is ruff. So ruff is a code formatter. It's a code linter. It's very quick, and it also can help you improve your code in general. So to use ruff, we can do something like, we have, let's say, some code here. Okay, so if I run this file, we get a drawing. We get a drawing that looks like this. We can see the code if I zoom out a bit. It looks like this. And what ruff lets us do is, if I open up a terminal, and make sure you have ruff installed by doing pip install ruff, I can do two different things that are very useful. One is that I can do a ruff, I can do a check, and I can check this file. So 05ruff.py. And it's telling me some issues that I have with this code that it doesn't like. We see all these different error messages. Just kind of gives us formatting improvements for our code. And you can kind of configure this so that it automatically does this when you're trying to commit code or push code, that it doesn't let you save it without like fixing these errors. But another thing that we can do that's cool is we can format it to adhere to certain standards. So if I, let's say, do a ruff format and I format this file, watch what happens to the code. We see that it now adheres to PEP 8 standards. Some of those like semicolons and stuff we saw on the screen are now removed. It just looks a lot cleaner. One thing that's interesting though is that we're not using some of these libraries. So if I check this again, we're still going to see that we have some issues. So we see that we have libraries that are not imported. One cool thing you can do with ruff as well is we could do ruff, and I want to show my screen again. Ruff, check this file, and then we can do -- fix and watch what happens to our code. Those issues, those unused libraries are automatically removed, and now we have, a much cleaner formatted file as well as a file that doesn't have unimported libraries. So ruff can be super useful for this. I will add a link to kind of some advanced ruff configuration settings and whatnot. But I think one cool thing that you can do is you could have ruff run automatically, like when you save your file or something like that. It might do this auto reformatting, and you can play around with a bunch of settings. So ruff can be super, super useful as well. All right, there were 5 libraries. 5, we did tqdm, the second one, which was rich, pathlib, pydantic, and ruff. 5 libraries that you'll be glad that you have met if you start playing around and using them. I'm going to try to incorporate them more into my daily workflows. Hopefully this video was educational and informative. If you like this video, make sure to throw it a thumbs up. Subscribe to the channel if you haven't already. And that's all. Peace.